Mining on Earth has disastrous consequences for the environment and the health and well being of communities living in the land affected by mining operations. According to a research paper titled Environmental, Hydrological, and Social Impacts of Coal and Non-Metal Mineral Mining Operations, mining negatively impacts the water table by using tremendous amounts of fresh water in processing, extraction, and disposal. Not only is the regional water table also affected, but also the local biodiversity, habitats, and the health of surrounding ecosystems. Communities can be negatively impacted by mining, even though mining provides jobs and valuable tax money to local governments. According to a research paper titled Environmental Impacts of Mining, a study of mining communities in Ghana, mining can deplete resources such as water, soil, the landscape, and including surrounding ecosystems. The paper concluded that the region they were studying for mining impacts, which was Priesti in Ghana, had several major rivers polluted and there was a loss in arable soil due to mining operations, especially illegal mining. Now you might be asking yourself, well, why can't we just end mining if it's so bad? A great question, but the reason why we can't do this is because of the fact that mining powers our civilization. If we eliminate mining, we wouldn't have access to metals or rare earth elements or non-metals that we use to build and power our civilization, our buildings, our houses, our factories, etc. So it begs the question, is there a way we can sustainably harvest these resources without any risk of hurting the environment or ourselves? Well, there's actually a place like this. It's a bit far away, maybe a few million kilometers or so, but it has much more resources to extract, and there is no environment or people to harm out there. It's called space mining, or more specifically, asteroid mining. According to a NASA webpage titled Asteroids Facts, asteroids are the remnants of our solar system's formation around 4.6 billion years ago and range in size and composition and are therefore classified into several types. But here are the three main ones. C-type asteroids are the most common type of asteroids and mostly consists of clay and silicate rocks. S-type asteroids are comprised of silicates and nickel-iron compounds, and the last one, which are N-types, consists of mainly metallic nickel-iron compounds. Let's imagine for a moment that you're a shiny new asteroid mining startup, and if you want to turn a profit, you're going to have to mine an asteroid, and there are several candidates for mining operations. If you want to narrow down the search, using classifications such as these would be very helpful. When it comes to what you want to mine, the ideal resource you want to extract are ores. According to a chapter in the journal Asteroids, Prospective Energy and Material Resources, titled Prospecting Asteroid Resources, ore, for example, could be precious metals like helium-3, water, organic compounds, or any other material. In short, any material that has commercial value. Before even mining, same thing with mining here on Earth, we need to prospect asteroids to find the ideal candidate. According to a research paper titled Prospecting Asteroid Resources, which was the same one we just cited a few seconds ago, there are three phases. The first phase is to identify a large enough sample size of asteroids. This could very well be the easiest part of the process, since we can use asteroid databases, which are already very widely available, to select candidates based on size, distance, and composition. DAMIT is an example of an asteroid database that stores information about population data or the number of asteroids. However, it also stores information of sidereal rotation periods, the spin axis, and the photometric data used or the inversion. The second phase is to go further in depth with the selected asteroid. We can select the potential candidates by using spectroscopy. Spectroscopy is the process of collecting and analyzing reflected wavelengths from an object to determine its composition based off the readings. According to a chapter in the book Asteroids 3 by the University of Arizona, titled Visible Wavelength Spectroscopy of Asteroids, the color of an asteroid, which is its fundamental characteristic, is made by the scattering or absorption of different mineral grains, the analysis of which can provide an insight into the composition of an asteroid's surface. Third and final most phase of this whole process is in situ characterization. To accomplish this, we must send probes to the asteroid to get more readings and more data, which is also then divided into two types: nearby and contact. The former is where we purely get visual data up close. The latter is to get surface samples of the asteroid. Even though this task seems daunting, the task of sending a probe to an asteroid millions of kilometers away, it has been done before. Just take a look at JAXA's Hayabusa 2 and NASA's OSIRIS-REx. They've both visited asteroids and even retrieved samples from them. So this task is indeed possible. Then finally, after all this prospecting, we can get down to mining. If you're still on the fence about mining an asteroid, here's a few reassuring words. Quoting from a student thesis titled Asteroid Mining, a review of methods and aspects, written by Vilde Helgren from the Department of Physical Geography and Ecosystem Science of Lund University, quote unquote, a future space mission to harvest asteroids seems prosperous and even plausible in the near future if using a cost-effective mission architecture, perhaps within even a decade. When it comes to mining asteroids, there's no one-size-fits-all. Asteroids are very diverse in their general makeup, composition, and geography, and therefore require their own unique way to extract their resources. According to a paper titled Asteroid Mining, a review of methods and aspects, there are several ways to mine an asteroid using the processes of blasting, heating, ripping, and disc cutting. Ripping is to tear off chunks of the asteroid's regolith to process, and disc cutting is to cut out neat chunks from the asteroid's surface to therefore process later on. However, heating and blasting are much more complex. According to a review paper titled Measurement of the Fragmentation Efficiency of Rock Mass Blasting and Its Mining Applications, blasting is the process of using controlled explosives to further fragment the rock into more manageable pieces. This type of mining is especially useful in asteroids with hard or friable rock, or hard rock metallic nickel or iron asteroids. According to a research paper titled Time-Dependent Finite Different Modeling of Outgassing of Asteroids via Bulk Heating, heating is the process of elevating the asteroid's surface temperature enough so that it will quote-unquote thermally liberate water and other volatile materials such as CO2 and sulfur that are present in the asteroid. Another interesting thing about heating, according to the paper, is that around 10 to 40% of the asteroid's mass will be turned into gas during heating, depending on the type of asteroid. Optical mining falls into the realm of heating and is the process of using solar radiation and concentrating that into a single focal point, which effectively creates a laser on the asteroid, which makes it a lot easier to extract resources in the form of gas. Transastra, a space tech company, has already done this before and have successfully tested it on an artificial asteroid. Just Google MicroMini-B. Just search up Mini-B ground asteroid optical mining demonstration, or just go onto their website. Even though asteroid mining has the potential to solve many of our problems and to accelerate our innovation and growth, there are a few reasons why asteroid mining hasn't been done yet. The largest of the two setbacks of asteroid mining is price and time. According to a research paper titled A Techno-Economic Analysis of Asteroid Mining, a hypothetical scenario of an asteroid mining mission that sought to extract water from an asteroid could cost around $5.7 million US dollars. This was the provided conservative estimate from the paper, and I'm not even mentioning the other potential costs involved. The estimated profits for the mission went as low as $139 million, which is in stark contrast to the cost, which was $5.9 million. It sounds like you can make a massive amount of money from this mission. However, the duration taken for the mission to complete was very long for both ends of the estimate, and the break-even point was between 5.9 to 0.29 years. And if you want your company to be successful, then you're going to need some very patient investors. The smaller yet undoubtedly large problem is the risk of failure. If a mission were to fail, which it has a massive likelihood to do in space, that would be very, very hard for a small company to endure. If it's a large company or organization, it would be very easy since you have a lot of money on board to weather that mission failure. One of the many things that could fail during a mission are the launch vehicles. According to a NASA research document titled Small Satellite Mission Failure Rates, the launch vehicle failure rates were around 6.1% during the years 2000 to 2017. Now, while this percentage is very small and is only going to get smaller as we innovate more, I'm still not even talking about the other factors that could fail during a mission. To a better understanding of the many things that could go wrong in space, it can range from fuelant issues to an error caused by the severe temperature fluctuations in the vacuum of space. However, to say that there is no innovation in this field, even though we haven't extracted anything from an asteroid yet, would be a wrong thing to say. One of the most interesting concepts that has come up, in my opinion, is the applications of biomining in asteroid mining. According to a research paper titled Biomining and Methanogenesis for Resource Extraction from Asteroids, biomining works by placing microorganisms inside or on the surface of an asteroid, and then those microorganisms will then transform the carbonaceous chondrite inside an asteroid into methane. Now, since we can extract methane from asteroids by using biomining in asteroid mining, we can effectively turn asteroids into gas stations. Because, first of all, methane is a biogas, and biogases can be used as an energy source. Also, liquid methane is a rocket fuel. Look no further than SpaceX's Starship, which uses methane as a propellant. You can even use gene editing technologies such as CRISPR to improve the efficiency and survivability of these microorganisms during their biomining stays. Interesting development is SCAR-E, developed by the Asteroid Mining Corporation and Tohoku University Space Robotics Lab. SCAR-E has a tremendous amount of potential in the field of asteroid mining because it can function in several environments, which makes it a lot easier to do in situ characterization of asteroids during the prospecting process. The success factor that SCAR-E has is just how rugged it is. According to the AMC, or the Asteroid Mining Corporation, SCAR-E can weather the severe radiation of outer space the immense forces exerted on it during launch, and the severe temperature fluctuations found in space. Interesting thing to point out is that while SCAR-E is intended for asteroid mining diagnostic purposes, it can also function in terrestrial applications by making diagnostic tasks and inspection tasks easier, for example, climbing up high places or getting into narrow spaces. Revisit Transastro with their creation of the Sutter Turnkey Observatory, or the TKO, which can house up to 18 different telescopes, function in a multitude of different regions and locations, and is portable, and has the ability to detect the faint glow of objects in outer space, such as asteroids. TKO is also able to function at the fraction of the cost of traditional observatories, and when coupled with Transastro's Theia, a software they made to make telescopes a lot more sensitive, the observatory becomes up to 100 times more sensitive. This innovation happening in the asteroid mining industry, it paints a very interesting picture for our civilization and how asteroid mining can influence many things of our future. If we were to replace Earth mining with asteroid mining, many communities and ecosystems that would have otherwise been affected by mining on Earth would be saved. Just to give you a reminder of what it's like, according to a research paper titled Environmental Impacts of Metal Ore Mining and Processing, a review, the reason why there's a massive amount of waste generated by mining on Earth is because the ores make up only a small fraction of the total mined material. One of the main arguments to why asteroid mining is superior to Earth mining is because the ore content in asteroids is significantly higher than the ore content in soil here on Earth. Another benefit of the increased resources provided by asteroid mining is the reduced price of metals, rare earth elements, and other materials that would have otherwise been a lot more expensive, which also makes it easier for countries to industrialize and to develop infrastructure that their citizens need. Mining could also increase the rate of innovation in the space tech industry. Let's just take a look at the invention of the internet. With the internet, we were able to play video games, stream TVs and movies, and communicate with people halfway across the world. We can expect the same thing with asteroid mining because this increased rate of competitiveness of companies pitted against each other to make the greatest amount of profits and have a bigger market share could lead to better propulsion systems as a way of companies trying to get faster than their competitors, which in turn benefits us as well. In asteroid biomining, you produce methane, which is a biogas, and biogases can be used in commercial applications, and methane especially can be used in space tech applications as rocket fuel. If we play our cards right, we can turn asteroid mining into another sub-industry that provides us with a set of clean fuel. In summary, asteroid mining can provide us with a utopian future. However, this is only possible if we take that first step to go there and mine an asteroid and bring the materials back. It will not be an easy feat, but as we keep on doing it, as more and more missions keep on going to mine asteroids, this will become easier as the path gets more traveled. And eventually we will reach our future with asteroid mining as a milestone.